Alright, what's up, gang? How we doing? We're on the third page of homework 4. Let's go. Okay, so I would like you to consider the following vectors on this question. We have a 5 meter, 30 degree north of east vector, an 8 meters per second, 70 degrees west of north vector, 20 meters per second squared, 45 degrees south of west, 4 meters at 15 degrees north of west, 7 meters at 40 degrees west of south, and 23 kilometers at 63 degrees west of south. So I'm going to go ahead and draw these up. North, south, east, and west. You don't actually have to solve this, but I am going to do it because it'll make visualizing this stuff easier. Reminder, by the way, for the purposes of, we'll get to that in a minute, I guess. So let's go ahead and draw these first. So A is 5 meters, 30 degrees north of east. North of east means you start at east and go north of there. So this is A equals 5 meters. This is 30 degrees. B is 8 meters per second, 70 degrees west of north. So west of north means you're going to start at north and go west of that. So that means that this is 70 degrees. This is going to be B equals 8 meters per second. 45 degrees south of west. So south of west is going to be start at west, go south of that. That's 45 degrees. This is C, which is 20 meters per second. D is 15 degrees north of west. This is going to be a little bit awkward, but that's okay. So this is D equals 4 meters. And then this angle is 15 degrees north of west. So it's north from west, right? E is going to be west of south. 40 degrees west of south. So this is going to be, drawing is not drawn to scale. E equals 7 meters. This angle is 40 degrees west of south. And then F is 63 degrees west of south. So we have another west of south one here. It's going to be pretty annoying. I apologize for drawing it like this. So west of south is going to be I'm just going to, here. West of south is like this. I don't want to overlay on these. So 63 degrees west of south is going to be 63 degrees. And then F is 23 kilometers. Okay, so here are our vectors. We have 5 of them. 6 of them, excuse me. Our first question asks us which quadrant these vectors is in. Pretty easy. This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. It goes counterclockwise for math. I'm almost sure. I just second guess myself. I'm going to really, really quickly look that up, but I'm pretty sure that's correct. Okay, I was right. Sorry. It's one of those things where it's you second guess yourself on something so simple. Yeah, it's 1, 2, 3, 4 are going to be our 4 quadrants here. So A is in quadrant 1, easy. B is in quadrant 2. C is in quadrant 3. D is also in quadrant 2. E is in quadrant 3 also. F also is in quadrant 3. So that first part's pretty easy. Now, we want to find the next step. We want to find the x and y components of each of these vectors. That's pretty easy. This is what we just did on the last page, right? So I'm going to go ahead and redraw all my vectors up here, down here again really quick. So A is this side's 5. This angle is 30 degrees. So we're going to go ahead and draw it so that our 2 lines are like that. B is like this. The length of B is 8. 70 degrees west of north. This is 70 degrees. So we're going to go like that and that to get B. C is going to be, C is like this. It's down. I'm just redrawing all the vectors that we just drew up here. C is 45 degrees south of west, so that means that this angle is 45 degrees. So we're going to get like that, and then C is going to be 20 on this side. D is 15 degrees north of west, so north of west is like this. That means this angle is 15 degrees. tuck that in here. This is going to be 4. E7 is 40 west of south. So west of south is like that. 40 is this angle. We're going to go like this and that to find our two sides. The angle is 7, or the side length rather is 7 here. And then F is 63 degrees west of south. So this is 63 degrees. And this is 23. Okay. So here are all of our vectors. I'm going to rewrite this 8 so it's also annoying. That's A, that's B, that's C, that's D, that's E, and that's F. So I went ahead and just rewrote them all down here so we can look at them all lovely. Now, we want to find our X and our Y components. We can do this easily by saying that our X components are horizontal lines and our Y components are vertical lines. I'm going to go through here and label them really quick, and I'm going to label them with the appropriate sign as well. So AX and AY, this is going up and to the right, so these are both positive. B, on the other hand, its Y component is here, its X component is here. It's going up and to the left, so our Y is positive, our X is negative. C, we're going to the left and down, so our X component is negative, and our Y component is negative as well. D over here, we're going up and to the left, so our Y component is going to be positive, our X component is going to be negative. E over here, we have down and to the right, so we have negative X and negative Y, and then F over here also will have negative Y and negative X. Okay, so now what we got to do for all of these, just the same as we have been, is we take sine and cosine of the angle, and we multiply it by the length of the vector, and we figure out which side is which by remembering about Leesburg, Ohio, touching your cosine. So touching side is X here, it gets cosine. Here we're going to do sine and cosine of the angle, which is 70 degrees, times 8, which is the vector length here. The side that touches the angle is Y, so it gets cosine. Sine gets X. Over here we do sine and cosine of the angle, which is 45 degrees. Touching side is the X, so X gets cosine. Multiply that by 20. There we go. D over here, we're going to do sine and cosine of the angle, which is 15 degrees, which is 15. Touching side is the X, so that gets cosine, Y gets sine. Multiply both of these by 4. That's how we do that one. E over here, we do sine and cosine of the angle, which is 40 degrees. Kitty, no. Sorry, my cat is meowing very sadly, wanting into my room. Okay, so sine and cosine. Cosine, the side that touches, is Y. X is sine. We take this, we multiply it by 7, and then over here we have sine and cosine. Oopsie. There we go. Sine and cosine of 63 degrees, the angle. Touching side gets cosine, which is Y, and then we multiply that by 23 from the length. Okay, so doing this, we can plug all this good stuff into our calculator here. Make sure to put our signs in front, and we'll do it. Alright, so first things first, we're going to do sine 30 degrees times 5. Sine was the Y component. So AY is going to be sine 30 times 5, which my calculator just told me is 2.5. Then we're going to take cosine 30 times 5, which is 4.3. Alright, next, B. We're going to take sine of 70 degrees. Multiply it by 8. That's our X component. Our X component is going to be negative 7.5. I marked that it was supposed to be negative over here. Our Y component, then, will be cosine of 70 degrees times 8 as well. That's going to be 2.73. I'm going to call that 2.7. And our Y component, of course, is positive here. Look at C. We have sine and cosine of 45 degrees. Sine and cosine of 45 degrees are the same number, which is 0.7 and some change. Multiply that by 20. We get 14.1 for both of these. So that's negative 14.1 and negative 14.1. Remember, they're both going negative. Over here in D, we have sine and cosine of 15. I'm going to look at sine of 15 first. We get 0.26. Multiply that by 4, that's 1.03, I'm going to call that 1. So our sine was our y here, that's positive 1. And then our cosine of 15 degrees is 0.97. We're going to multiply that by 20 degrees, or 20 length rather. Our x is negative, so our x component is going to be negative 19.3. All right. Vector E now. So sine of 40 degrees will give us 0.64. Multiply that by 7. We said sine was our x component over here, so our x component is going to be negative 4.5. Now cosine of 40 degrees times 7 is 5.4. It's negative as well, so it's going to be negative 5.4. Okay. So lastly, we have vector f, which we can take. We said that the x was sine and y was cosine, so we take sine of 63 degrees, multiply it by 23. That's 20.5. So fx is going to be negative 20.5. And then y, we have cosine 63 times 23. It's going to be negative 10.4. Both of those sides are negative again, looking back at our drawing. Okay, so that's how we find our x and our y components of these 5 vectors. So far, so good. Next up, we're going to move on to the next page. I'll see you guys in another one.